Science, including a lot of chemistry, physics, and geology, played a big part in the Texas story. Much of human history involves learning how people harnessed and directed energy. But what exactly is energy? A simple definition is the ability and possibility to do work. Energy largely falls into two categories. There is potential, or stored energy, and there is kinetic, or energy in motion. Observers may not be able to see energy, feel it, hear it, or taste it in its most basic form, but it has always existed in one of these states. People can certainly see energy working. People encounter or interact with 9 kinds of energy, even if they don't know it at the time. Potential forms of energy include chemical, electrical, elastic, and gravitational. They have potential because it is stored energy, like electricity in batteries, or tension in a rope, or the long, slender shaft of an atlatl. Kinetic forms of energy include heat, light, dynamic, sound, and nuclear. The sun is a large kinetic energy device as it converts the potential energy of its hydrogen fuel into a form of nuclear energy through the process of fusion. That process also creates heat and light. Here's the tricky part. Energy can never be created or destroyed. The amount of energy in the universe stays the same, but it often changes forms. That is what scientists call the law of conservation. That campfire? Well, heat and light from the sun is kinetic energy, converted into the potential energy of wood. Think of that log as a chemical energy battery. Burning that wood transforms it and its stored energy into thermal and radiant energy, both kinetic forms. The video you're watching is delivered using electrical energy. The fact that people are not floating above the ground is through the effects of gravity, another kind of stored energy. Motion, a kinetic form of energy, helps people get to school and work. All human history has involved the quest for better and more efficient ways of converting one kind of energy into another. The people gathered around the ancient campfires had themselves transformed food, plants and animals, into other kinds of energy. They walked around. They threw spears. They cooked. Power is different than energy. Power is the ability to do work by supplying energy to a task. Technology creates and uses power. For instance, the ancient hunter used energy to create power to make the spear, his technology, to which he applied more power into kinetic energy to fling his creation toward its target. Whatever he ate, his food, had been converted into the power to work his muscles. There's a lot of energy conversion, technology, and power just in that one simple act. Inventors and scientists made strides through the centuries in efficient ways of converting energy into power. And by 1900, their discoveries had been truly astounding. Humanity had gone from relying on human, animal, and wind power to widespread use of machines. Machines were the first energy multiplier. They allowed the better use of stored energy to be converted into kinetic energy with less loss to outside forces. This allowed people to spend more time thinking and less time doing. As a result, the scientific search for easy to convert and easy to transmit energy fueled much of the industrial advances of the 19th century. which leads us to oil. Some might think of it as prehistoric dinosaur goo, but it is more like 300-million-year-old salad. Plants, even ancient ones, act like super batteries. They absorb the sun's energy and store it in their cells. When ancient plants died, especially in swamps and marshes, sediments made up of those plant cells decomposed into a substance called kerogen, often referred to as the mother of petroleum. It is a carbon-rich, rock-hard material riddled with holes of various sizes. Pressure and heat cooked that kerogen over millions of years and squeezed out the oil and gas. When machines fueled by petroleum do their work, they are actually converting stored energy from sunlight that hit the earth millions of years ago into kinetic energy to power the task at hand. This remarkable process is a great example of the law of conservation in action.